Congratulations on completing the Python basics. That's quite an achievement, and now you know how to write lines of code, blocks of Python code. You also know how a program looks like. It's still hard for you to make a program from scratch, but that's what the rest of the days are for. So from now on, you will be building applications. We will be building them together, and then I'll give you tasks so that you can build your own projects. So there will be a combination of instructor-led projects and student-independent projects. However, today we have to stop for a while and do a revision of what you learned so far. So whatever you learned from day 1 to day 19, today, which is day 20, you'll be reviewing all those concepts. I would recommend you that you treat yourself perhaps with a coffee or tea, sit back and just watch the videos, so you don't really have to type in anything today unless you want to. So today's videos will consist of me covering the basics from a different perspective, so that might fill any gaps that you have in your knowledge about basics, if conditionals, variables, lists, and everything that we learned throughout the previous days. So let's begin in the next video. I'll see you there. Hi, this is the first video of the revision series. In this video we will focus on PyCharm. This video is important actually because throughout the course you will be opening and closing PyCharm, you'll be creating new projects, and sometimes you might have problems with the virtual environment, with the Python interpreter. So in this video I want to cover those possible problems so that it can save you some frustration. So let's say you have an existing PyCharm window open and you want to create a new project. So you go to File, New Project. You pick a directory where you want to save your project or create a new folder if you don't have one, for example, revision. So in this folder I'm going to put all the files that I'll be showing you today. So then normally you press on New Environment, choose an interpreter, for example 3.11, and press on Create. This might ask you if you want to open a new window or override this existing PyCharm window. You can override this if you want to close that existing window, and so this will be your new PyCharm project. Now, to make sure that everything is working fine, you might want to check the terminal, and if venv here is displayed before this part, that means the virtual environment is activated and you can begin installing packages here if you like, or you can install packages from the Python packages section in here in PyCharm. But always make sure that venv is displayed here. What happens sometimes is that after you close this project and you reopen it again using file open, so let's say we open this project again, which is in here, revision, you open it again. Sometimes what happens is that you might get a message here which says that the virtual environment has a problem. In that case, what you want to do is you want to go to the settings of PyCharm, which can be named settings or preferences. They can be in PyCharm or inside the file menu, or you can use the shortcut command comma or control comma. So in settings, if you have that problem with the virtual environment, you have to go to project and then to interpreter in here, and then go in here and then go to add. So you want to access this window again, right? And then you might first try to go to the existing environment and then go to this, and there you might want to press OK. So that will select this venv folder, right? and that should fix the issue. If that doesn't fix the issue, then you might want to add a new virtual environment with that button, but first you want to delete that folder, that event folder. So you can delete that, remove it entirely from your project directory, and then go back to the interpreter, go here, press on add, and select new environment. So that will create a new Venv folder. Press OK, OK here again, and then you should be able to see Venv here in the terminal. And then carry on with installing packages and also, of course, creating new Python files and start coding. So that's a review on PyCharm, and that was also some pre-help in case you get this issue, and it happens quite often with virtual environments in PyCharm, so please keep this in mind. And yeah, let's move on to the next video. Thanks. Hoping that you are enjoying the videos, let's start with the very first video on this series of revisions, reviewing the basics of Python. So I'll be showing you code here, and you have two choices. Either you can just watch these videos without doing anything, or you can start a PyCharm project and then write the code either in .py files or just use an interactive Python console. On my end, I've placed the code already in something called Jupyter Lab. So what you're looking at is a tool called Jupyter Lab. In Jupyter Lab, you can write in code and execute it, but that is something that you learn in day 30. So Jupyter Lab is good for presenting out code to other people. So for now, you don't really need Jupyter Lab, so please focus on Python code. Right, let's start with the first concept, objects and variables. So we have some main topics, and these topics have subtopics. So objects can be stored in variables, right? John is an object, Smith is an object, and this number here is also an object. All these are strings actually. So everything that is wrapped in double quotes is a string, even when that is a number. So these are actually real numbers. This is an integer and this is a float. Now you'd ask, oh, how do I know when to use quotes on a number and when to use the number without quotes? Well, the answer is that if that number has mathematical meaning, then you should use the number without quotes. But if that number will not be used in mathematical operations such as addition or multiplication, etc., such as is the case of the ID here, then it should be a string. So all these here, all these objects, John and 5 and 1.75, are stored in variables. But sometimes objects can be produced by functions. For example, we have this variable here, and this variable is associated with the call of the input function. So when this input function is called, when it's executed, then the user will enter a string, for example, rdid, and this string will be stored in that name variable. So this is indirectly. In this case, we store the objects directly in the variables, and here is indirect. So when we call that variable, when we print it out or you just call it in the interactive shell, you should get something like this. So that's the string that was stored in the name variable. Sometimes though, you have to be careful with types. Let's see this other example. This is asking the user to enter the height. So the user enters the height, and then this height is stored as a string. So this is not what you might want here, because this has some mathematical meaning. It could be subtracted or added to another number. So in that case, you can use converters such as a float or int. So in this case, this is the same code as this, but in addition we have this float with parentheses here and parentheses there. So whatever the user enters here, that will be converted into a float. As you can see here, name is 175.0. So that brings us to the next topic, which is functions. So that was a function, input was a function, print is also a function. Now, not all functions return a value. This is something that you really should understand. For example, the print function does not return a value, right? So in the case of the input function, here or here, the input function returned a value which was 175, and that value is stored in the name variable. But some functions, such as the print function, doesn't return a value, right? So in x, if you print out x, you'll get nothing because there is nothing stored in x. This, however, doesn't mean that the function isn't doing anything. So the function might still be executing some procedures, for example, printing out some text on the command line, right? As is the case here. But don't confuse that with the returned output. Let's take another example with custom functions. So that is a function which you can create. And this particular function is indeed returning a value. So this function is basically similar to the input function in that it returns a value. And the value is returned with this returned keyword. So when you do foo, so the name of the function, when you call that function and you associate it with a variable, in x you will store whatever you return in here. So x will be equal to 10. But if you write another function definition which doesn't have a return statement, so no return statement here, and then you call the function and you try to store the output in x, then x will have nothing associated. Well, in some terminals, in some consoles, perhaps you'll get a none printed out, which is some kind of value actually. It's a kind of object type, like we have strings, we have numbers. This is also a type of value, but it means that it's a nothing value. So make sure to return a value if you want the function to give some output. So that brings us to the issue of return versus print. So this function here, foo1, has this value variable declaration, and then it returns that value. It should be value, not 10. So it returns 10 basically. And this function here, instead of returning, it prints out the value. Now, to understand the difference between that and that, you should call the function. So let's call the first function foo1. We store its output in x1, and x1 will be equal to 10, right? Because it returns this value here, which has a value of 10. While x2 is equal to foo2. And now notice that if you do this, the function foo2 is being called, and when the function is called, print is executed. That means you will get an output when the function is called. However, in here we didn't get an output when foo1 was called. You don't get an output because there is no print function here inside this function, so nothing will be printed out. However, the difference is that the first function will store a value in x1. You see, x1 will be 10, but x to here will be equal to nothing. Right, so that is the difference between return and print. Functions can have parameters. So these functions here didn't have any parameters, so the parentheses are empty. But this one here gets a parameter and it processes that parameter and it returns some results. And then you can call that function by giving a value to that parameter, or now you can call it an argument. So when we're talking about the function definition, we usually refer to that as a parameter, but then in the function call we refer to that as the argument. So number is the argument and 10 is the value of the argument. So the function will get the value 10, it will do 10 times 10, 100, and it will return 100. So 100 will be stored in x. So x is 100. Now, this here was a function call with an argument name. And this here is also a function call but without the argument name. So these two produce the same results, but the way you declare the argument changes. So it's just a change in the style of the code. The functionality doesn't change. Which one should you use? Well, both have their advantages and disadvantages. So this here tends to be a bit more readable because you know that 10 is the number argument, so you know what 10 is. And this here is shorter, so it's cleaner. So you have to choose between shorter code and cleaner code. And usually if it's clear what arguments you are passing to a function, for example, if this was a function that says calculate square, then you know that this function is calculating the square of a number, so you can just pass 10 and you know that you are calculating the square of 10. So that's the idea here. Then we have functions with multiple arguments, so you can pass multiple parameters in the function definition divided by commas, and then you can call those parameters, those arguments. Again, you can either do number 1 is equal to 10 or number 2 is equal to 20, or you can just pass the values without the argument names. But be aware that if you pass the argument values only, you should respect the order of the parameters. So 10 will go to number 1 and 20 will go to number 2. Right, functions with default parameters. So this here is a default parameter. It has a default value, which means that when you call that function, which is what we're doing here, and you are okay with that argument having that default value, which is 2 in this case, then you don't have to pass that argument in the function call. But if you want to pass that argument, then you can do so, as I've done it here. Right. That was on objects and variables and functions. In the next video, let's talk about methods. See you there. Let's continue talking about methods and how they differ from functions. So, unlike functions, methods are associated with a certain type. For example, strings have an upper method which will capitalize all the letters of strings. Strings also have a capitalized method which capitalizes the first letter. They have a title method which capitalizes the first letters of each word in the string. And of course, methods can also be applied to the variable which is holding the object. So in here, we apply the method directly on the object itself, and here we apply it to the variable which holds the object. Either way is fine. But normally, you work with variables when building applications. So most commonly, you'll do this here. Now, there are methods which return an output and methods which don't return an output. And this is a concept similar to functions. Functions which return an output and functions which don't return an output. This method here, title, is applied to the greeting variable which holds the string hello there. Now, when you execute this code in a Python console, you will get this hello there with H and T capitalized. So this means that this method is returning that string. Or you can also have this stored in a variable words is equal to hello title and then print out the words and you'll get the same thing. Hello there. So the output of title is stored in this variable. In other methods though, such as we have this append method which applies to the groceries list. So this method does not return an output. So if you assign a variable here, such as variable equal to that, the variable will be equal to nothing because no value is returned from the append method. However, the append method modifies its object. A method modifies its object when the object is mutable. So lists, all lists are mutable. Strings are not mutable. So if I print out groceries here, you'll see that apples has been added to groceries. So groceries was a list of 3 items up here, but then here it became a list of 4 items. Similarly, we can apply a sort method to groceries. So this sort method will not return an output, but it will modify its object. So this is not the same as the title method. Title returns an output, but it does not modify its object, because the object here is a string and strings are immutable. They cannot be modified. If you really want to modify a string, you would have to store the new output in a new variable. For example, greeting new is equal to that, and then greeting new will be the new string with H and T capitalized. But it's a new object, right? You're not modifying the existing object which is currently connected to the greeting variable. Right, that's about methods which apply to mutable objects and methods which apply to immutable objects. To get a list of methods for a particular object type, you can use the dir function. For example, for strings, you can do dir str, and you'll see that, for example, you have the lower methods here, the title method, which we used, also the upper method, etc. Alternatively, you can also apply dir to an instance of strings. So hello is an instance, right? str is the class which represents all strings. So a class is like, for example, let's say here we could say human, and so the human is the class, right? But then if you refer to a particular human which has a name and he lives somewhere or she lives somewhere, has an identity and so on, that is an instance of a human class. So the person, one particular person is one particular instance. And the abstract concept human is the class. So the same goes here. str is an abstract concept. And hello is one instance of that concept. Of course, you can apply dir to other object types such as list. This could be int as well, float, etc. How to create new methods. So for function, for example, we have functions which we access from Python, for example, the print function, the input function, but we can also create custom functions using the def keywords. Now, with methods, we have these methods, for example, upper and title and append. But how do you create new methods? Well, since methods are connected to their object types, then first you need to know how to create object types, right? How to create a human blueprint, for example, how to create a string blueprint. That is something you haven't learned yet, but you learn that in the second half of the course. So that's an advanced concept, and that's the ultimate level of Python you can get. So once you know how to create these types, object types, then you also learn how to create methods for these types. So perhaps you can create an app, a booking system for airplane tickets, and you'd have like a ticket class, a ticket type, which would create ticket instances for customers, and then this ticket class could have a cancel method which cancels the ticket, or a delete method which deletes the PDF ticket, or it deletes the ticket from the database, and so on. Lists and tuples. So that's a list, that's a tuple. What's the difference? Well, tuples are immutable. So for example, you cannot have an append method for this values tuple. You'll get an error if you try to execute that, because the append method is meant to modify the object it applies to. But tuples are immutable, so this will not work. Usually, lists are used when you want to store homogeneous items. For example, this list contains strings only. Even though you can store various types, but usually you want to use lists for homogeneous items. And you also want to use lists when you foresee that during the course of the program, in the program, during the execution, the list may be changed, new items can be added to the list, and so on. That is something that you'll better understand when you build real applications throughout the course. And tuples are more meant to store heterogeneous items. For example, let's say you have a web app where the users can upload an image and they want it resized and they want it grayscaled. So they may input some numbers in input boxes in the web app interface. And so in the backend in Python, you will get those numbers in a tuple. You might get the grayscale string, so the user is saying that I want it grayscale and I want it a JPG, so you may store such data in a tuple. Right, indexing. You can use indexing on strings, lists, and tuples. For example, groceries 0 will give you the first item of the groceries list. Groceries 2 will give you the third item. So 0, 1, 2, that's the third item. The same goes for tuples, so that will give you grayscale, the third item. For strings as well, so n is the third item with index 2. And we also have negative indexing. For example, -2 will give you A, this, because R is -1, A is -2, -3, -4, -5, and so on. You might want to use negative indexing when you're accessing items which are closer to the end of an array. Array, I mean a list or a tuple or a string. Also called sequence. So these are also known as sequence types. Of course, this is a string type, this is a list type, this is a tuple type, but they fall in the category of sequences. So that's how you access individual items. But you can also access a slice by using that colon symbol. So that will give you the items from index 1 up to index 2. So the item with index 3 is not included in the slice. So you only get 1080, which is this. So 0, 1, index 1, and index 2, grayscale. So that's the rule for indexing. It works for strings and lists as well. Then we have negative indexing. -3, -1 means from here, which is -3, up to here, which is before -1. So always the second index in the slice is not included in the slice. So index 3 was not included here. Index -1, JPG, is also not included in this slice. Lastly, for this video, let's talk about dictionaries. You should use dictionaries to store your data when your values are more heterogeneous, and it's important to have labels on them. So the data here are, for example, John, Smith, 40. And so these are heterogeneous because these are strings, right? And this is a number. And their labels are first name. So this tells you that John is a first name. Then we have last name. So Smith is a last name. And then we have age, which is 40. So these are known as keys. First name is a key, last name is a key, and age is also a key. And the values of this dictionary are John, Smith, and 40. Dictionaries can also be inside other items such as lists. For example, here this is a list. It starts in here and it ends in here. You see the square brackets. So this list has 3 items. That's the first item, that's the second item, and that's the third item. So each item is a dictionary because a list can have any type of object, and dictionary is also an object, just like we have strings and integers and floats, etc. So this structure here would be appropriate if you had multiple persons. So you would store data about those persons and you'd have the same key in all the dictionaries but different values. For example, John here, Smith, and the age. And you repeat that information but with different values, right? So that's one way to store these data about persons. However, in certain applications, depending on the scenario, you may want to store those data differently. For example, here we also have data about persons, but this will be a dictionary. So it's one dictionary, it starts here and it ends in here. And then this dictionary has keys and values. So the keys are the same, they are just strings, first name, but the value is a list. So the value of each key now is a list instead of a string. So this list here has the first names of all the persons, and then we have another key which has also the last names of the persons and the age. Which one is better? Well, there's no answer for that, whether this is better or that. So it depends what you want to do with these data. Do you simply want to print them out, or do you want to modify them? That is something that you'll realize as you build the application. So nothing to worry about now, what is better or what is not. And lastly, to access values of a dictionary, you use that syntax. So you refer to the variable which holds the dictionary, John, in this case. And then in square brackets, you refer to the key in quotes. So that will give you Smith, the value of the last name key of the John dictionary. For this here, which is a list, you'd first have to do 2. So with that, you'd get this dictionary, because this list has 3 items. So that has an index of 0, that has an index of 1, and that has an index of 2. So with that, you get the last dictionary, and then from that dictionary, you access the first name key, so that will give you Sim. That's what we get here, Sim. Since this is a dictionary, first you have to give a key. So here you gave a number because that was a list, but here you have to give the key of the dictionary, first name, and then this up to here you will get the list as output, and then out of that list you access index 2, so the item with index 2, which corresponds to Sim, so you get Sim as output. That's about this video. We have some more. See you in the next one. Next topic to be revised is code blocks. By code blocks, I mean things like while loops, for loops, match case, if else. So these are multiple lines of code which have to stand together. For example, these 2 lines here make up a while loop. So if you start with that line, you have to write the next lines indented under that line. So that's like a unit, a code block. Now this while loop here is an infinite loop in the sense that this will run forever because this condition here is always true. So that means this line will be executed over and over again. It will ask the user to enter input once. The user will enter that input, then it asks the user again to enter an input twice, thrice, etc. While this here will run until this condition is satisfied. So this is some sort of finite loop. So it will ask the user to enter a password, but if the user happens to enter pass1 in the command line, then this condition will not be satisfied anymore, because this condition says that, oh, run this until the password is different from pass1. So if the password is the same as pass1, then the loop will not run anymore. And after the loop runs its last iteration, then the code after the while loop is executed. So in this case, password is correct will be executed. For example, this is what happens. The user enters pass is not the same as pass1, so the loop will run again. Pass2, it's not the same, the loop will run again. Pass1, yes, pass1 is the same as pass1, so in that case the loop will not run again, so password is correct will be executed, this line here. For loops are also loops, but they are designed to run as many times as there are items in a sequence, such as a list. So we have this usernames list here, and so this loop will iterate 3 times. It will go through each of these items and then capitalize that item and print them out in the terminal, as you can see here. Match case. Match case is a control flow code block. Let's see how we would use it here. So this program asks the user to enter a username. So the user enters a username, sim. And so the program then tries to match the user's value, so this variable, username, it tries to match the value of that variable against several cases. In this case, it will execute print welcome user because the user entered sim in the command line. So match case can be used when you are simply trying to find out if a value is the same as another value. But for more complex comparisons, for example, in here we have this password pass and then this conditional block if else. So this now is trying to apply a more complex condition. If the length of the password is greater than 3, it will do this. Else, if it's not greater than 3, it will say password is weak. So an if-else conditional block is more appropriate for this scenario. And a conditional block can also include an elif condition. So when you want to count for more than 2 cases, for example, if the length of the password is greater than 3, print that. If the length of the password is equal to 4, print password is medium. Otherwise, password is weak. So this line here will only be executed when this condition is not evaluated to true and this condition also is not evaluated to true. One more topic for this video, f-strings. Let's consider that we have some values stored in a variable, or maybe some functions are producing these values, right? If you want to construct a string where you want to enter some dynamic values, for example, some strings which are stored in some variables or some functions, then you'd use this syntax. So you start the string with an f in front, and then inside the string you either enter literal text or you enter variables, but variables should be entered inside curly brackets. You can also add some simple code in these curly brackets. For example, here I have the variable and I've applied the capitalize method, and this expression will return that string but with the n capitalized. Of course, you can also keep it like that if you don't want n to be capitalized. And of course, you can enter more than one placeholder, as we have here too. So message now will be containing that content with Naya Anand inside the string. You'll see how f-strings will become very useful in almost every application that we will build. And that's about this video. In the next one, let's look at external files. See you there. So far in this revision, we have worked with code which processes internal information. So information inside the script itself. So getting a string from a variable, capitalizing it, maybe getting some input from a function, processing it. So the Python file was not communicating with any external files, but that is not always the case in real life. So in real applications, you have to process external files. That's why now we need to review external file processing, and we're working with text files, which are the most common type of files. So creating files, how can you create a file from Python? Well, using that code. So the open function will create a file object, and that file object will be stored in this variable, right? So file will be equal to this file object. Then in this file object, you have to write content. So the write method belongs to this type of object. So it's part of the file object type, and it expects a string. So if I run that, that will create a book.txt file. So this is a case of writing files, and the key here is that you need to provide this y argument for writing. Now, another version of writing files, writing content to a file is this here. So this was just a one-line string, a simple string, but sometimes you may want to add strings which span across multiple lines. In that case, you want to use a multi-line string with triple quotes here and triple quotes there. You store that in a variable, and then you apply that code again. And the only difference here is that you are providing the variable content here instead of writing the string directly. You can also write the string directly. You can cut that and paste it here, but that is not very readable. It would mess up the code here. So whenever you have multi-line strings, please store them in a variable first and then use that variable in your code. Something to note is that if I was to run this script, it would create this book.txt file, right? And then if I run this other script, this would override that book.txt file. That is because the name here and the name in here are the same. So this would override that previous file. And another thing to note is that the files will be created in the project directory. So if you are working on PyCharm, you have a .py file where you have the code, and this file will be created in the same folder with your .py file. But if you're using a Python console, then it's important to know where the Python console is pointing to, what directory it is related to, where did you open it from. So the current directory of the Python console is important here because that is where the file will be created, in that directory. Then we jump to reading files. The difference here is the R arguments and the read method. And also, of course, here we store the output of this in this variable. So this returns a string, and the string represents the text of that file. So this file has to exist in the current directory, in the project directory, for you to be able to read it. So for example here, if I call this variable, I'll get this. Right. That is the text that I wrote in here, up here. Now note that we have these \n and they symbolize break lines. So when you just call the variable like that in a Python console, you may see these as \n, but if you use a print function to print that variable, then the \n will be rendered as actual break lines. So we have a break line in here, and we have a break line in here as well. Lastly, the readlines method. So you see that the difference of this and that here is the method. This is readlines, this is read. And of course, this time I'm reading another text file. I did create this text file up here using the writelines method. So writelines is the homologue of readlines, basically. With writelines, you provide a list of strings. But with writes, you provide a string. So write lines will write each of those strings in a separate line in the text file, and read lines will read every line as a separate string and produce a list of those lines. It's important to use a break line after these lines in here if you want them to be separated in separate lines, right? And then when you read this, of course you will read it together with those \n as you see here, down here. So if you want to get rid of those ends, you can use list comprehensions. So what I'm doing here is I am iterating through the items of the content variable of this list through each of these strings. So for each string in the content list, I am stripping out the string from those \n. So strip will remove those characters. And so clean content will contain this list now. So clean content is the variable that we created in here. And that's about this video. We have one more and we're done. So see you in the next one. As a programmer, you'll spend 60% of your time coding and 40% of your time fixing bugs. So it's very important to understand what errors are and how to fix them. So let's revise errors. We have two types of errors actually. We have syntax errors and we have exceptions. So syntax errors are errors which happen before the interpreter compiles the code. So first, the interpreter just checks the syntax, right? It looks if you have the brackets correctly, the commas, the dots. For example, this line here, this starts with a square bracket, but it ends with a parenthesis. The correct code would be to have a closing parenthesis here. But that is not the case, and that's why this code will return this results. So this is a syntax error, an error which happens before the code is compiled and executed for the processor. So this here tells you with this arrow where the error is. So closing parenthesis does not match opening parenthesis, right? That's quite clear. But error messages are not always clear. Let's look at this one here. Right? So we have this opening bracket, we have this closing bracket, that's fine. But instead of the periods between the variable and the method, we have a comma here. So this should be a period. In that case, we get a syntax error, of course, because the syntax is not correct, but the error is not so clear, the message. It says that we forgot some parentheses around the comprehension target. So the interpreter looks at these two and it thinks that perhaps you meant to have them inside parentheses like that. So it's not so clear for the interpreter to understand what you're actually doing. So in that case, you should look carefully at the code and try to use your experience to understand where the syntax error actually is. So in that case, this comma should be replaced with a period. So these two were examples of syntax errors. Then we have exceptions. This code here is syntactically correct. So all the symbols and the rules of the language syntax are respected, but the problem here is that we have this variable which doesn't exist. So the variable name itself is fine, it's syntactically correct, but it has not been declared in the script. That's why we get this name error. So we have syntax errors and we have name errors, and then we have attribute errors, which is produced by this code. For example, this is an attribute error because this method here has been mistyped, there's no such a method for strings. The correct method would be strip. So in that case, you get this attribute error. So a method is actually an attribute. So here we are trying to access that strip attribute out of the string object. That's why we get this error. str object has no attribute strip. So such errors are caught when the interpreter is trying to compile the code to make sense of the code. Here is another example. So we ask the user to enter a number such as the year of birth, and then we have this variable current year. Then we want to calculate the age of the person using the current year minus the year of birth for that person, and we print out age. But the user didn't enter the actual year, but they entered something like this, right? In that case, this produces a value error. It says that this thing cannot be converted into an integer. So the int method expects something like a string which contains a number inside, for example this here. But this is not really a number, it contains some dots and things like that. And that brings us to the topic of handling exceptions. So these are exceptions: value error, attribute error. These are known as exceptions. And try except helps us to predict an error. So we get that code and we transform it into this code. So we try to get the input from the user, we try to convert it into an int, and then we try to calculate the age, and then we print out the age. So if the user will enter the year correctly, for example 3001, then this code will be executed. So in other words, when there are no errors, this code will be executed. But if this code produces an error, then Python will execute this code. Now it's better that instead of doing except here, you should mention the actual error that you accept, which you expect. So in this case, we expect a value error when the user doesn't enter a correct format, right? Like this one. So it's better to specify the error specifically in here. Now, this line here, it's better to keep it outside of this try except, because you don't really expect an error in this declaration. So mostly you want to put these dynamic codes inside the try block. So whenever possible, try to put other code outside of the try block, if you can. Otherwise it's fine if this was also inside this block somewhere in here, right? That would also be fine. It's important to know that try except does not catch syntax errors, because try except only catches exceptions which are caught when the interpreter is trying to compile the code. So this code here, for example, has this age variable which is missing a parenthesis. So in that case, if you run this code, you'll get a syntax error. So the try block, the try clause will not be able to catch that syntax error, which is a good thing. So first of all, you always want to have your code syntactically correct, then you catch other exceptions. And then you might have the question, oh, when to use try except and when to use if else. Well, here is an example of when you'd use if else or if else. So the try except block always catches errors. It doesn't catch logical errors or logical cases. For example, if you want to tell the user that, oh, the age we calculated for you is too big, then you would want to find that out with an if condition here. Because the interpreter doesn't know what a normal age is. It doesn't know that humans cannot be 150. So you have to use if-else blocks for that. Right, next topic, comments and docstrings. So this here is a docstring. Docstrings are used to document what a function does. So you place them inside the function definition. And you use these triple quotes here and there. So this function is then called in here, and then for commenting single lines of code or blocks of code which are not functions, then you use comments. So this comment here is trying to tell us something about the next line which is placed under it. So this one. But try to not overuse comments. For example, I think this comment here would be unnecessary because it's clear to the programmer that you're actually calling the function here. So you can omit this comment. So you only want to comment complex code which you think that it will be harder to understand if you come back 2 weeks after or something like that. Modules. Modules are Python files which can be imported into another Python file. So basically when you import my file is a file named myfile.py. And so when you import that Python file, you are making available all the functions and the variable that script has inside. So in here, let's say this myfile.py script had this area function defined. So let's suppose that this area function was defined in myfile.py. In that case, we can access that by referring to myfile.area, and then we call that area function and get the output in a variable. Standard libraries are also Python files. They can be one single .py file or multiple files. For example, glob is a standard library, request is a standard library. So these are libraries which you don't have to install. These are included with Python. So you just import them, and then of course you use them similarly as we did with this. So myfile.area glob.glob. So glob is a function in the glob library. Area is a function in the myfile module. So this is a local module, and this would be a standard library or a standard module, you can say, depending on whether this is a single file or multiple files. So that particular function, glob, would return this list. Now, sometimes you don't really know if that is a method or a function. So if glob is a library or a module, then this is probably a function. But if this was a class, then this would have to be called a method. Now, it doesn't matter much what you call this, a method or a function. But if you really want to find out, in PyCharm you can right-click and then you can go to the Go-To menu and then go to Implementations. And there you'll see what this really is, if it's inside the glob.py file or if it's inside a class. Right, so here I've also tried to use the get function of the requests library. So that is used to get the contents of a website and then print it out. So the content is HTML, as you can see here. It also contains other information which is inside the HTML. for example this text here, and so on. Third-party libraries are libraries which have not been included with the Python interpreter, so you have to install them with pip install followed by the library name. Their behavior is of course the same as the standard libraries, so you use them using the same syntax, of course. Web apps. Web apps need a third-party library, also known as a framework, a web framework such as Streamlit. So we did use Streamlit in the course, and we'll use it again to create more complex web apps. So I'm not going to go deeper into explaining web apps because we're going to work over and over again with them throughout the course. We also covered PY Simple GUI, a library to create desktop GUI apps. We're going to have more GUI apps in the course, so I'm not going to explain those here as well. So you have the chance to practice these over and over again throughout the course, either by instructor-led projects or by your own projects, which I'll give you. I'll hand you out the exercises, the requirements, and you'll be able to work on your own. So thanks for following this series of reviews, and let's move on to the real part of the course, building applications. So it's going to be fun, I promise, and I'll see you in the next videos too. Computers in the past didn't have a graphical user interface as they have today. So today we can use our mouse cursor, we can click on widgets, we can fill in text boxes, click on buttons, etc. So what we use today is the graphical user interface of the operating system. But back then, our ancestors, well, our older colleagues, didn't have a graphical user interface. All they had was a CLI, command line interface. So they communicated with the computers using commands only, text commands. This command line interface, though, is still here in our computers. So if you go to your start menu on Windows or Mac or Linux and search for CMD or terminal on Mac or Linux, so you should be able to open that same command line. And in this command line, you can navigate through your computer and you can still use your computer. However, normal users don't really need to use this command line. Nowadays, the command line is only used by computer admins or programmers. So as a programmer, it is important for you to know the main commands that you can use on a command line interface. Why is that important? Well, because sometimes, for example, we used the Heroku servers to deploy a web app. Now, Heroku is a server, so we don't have access to its graphical user interface. We only have access to its command line interface. So if you want to deploy your apps, your programs, your code to a remote server, the only option you have is to control that remote server through the command line interface. That's why in this video I'll teach you how to use the command line interface. So if you are on Windows, please close the window command prompt and you should open the git bash. So I assume you have installed Git already. If not, please search for Git download on Google, go to the first page, downloads, and then go to Windows, so download for Windows, and that should download either a 32-bit or a 64-bit Git executable. So then you should install that executable. Just click on next, next, next. If you have troubles, you can look at the programming tool lecture in day 15. There is where I showed you how to install Git. So I have installed Git already. So once you install Git, then you can search for Git bash and open that. So this now is... So that is for Windows users. For Mac and Linux users, please search for the terminal app and open the terminal app. So both the Git Bash and the terminal app can be used to work on your computer or on a server. It doesn't matter if it's a local computer or a server. So you can use the Git Bash or the terminal to do things like create new files, delete files, go to a certain directory, edit text files, etc. So once you open the Git Bash or the terminal, then the terminal or the Git Bash will point to a certain directory. To find that out, what directory you are currently, press pwd, and that will tell you where you are. So I'm currently at C users AS. So that's the first command you just learned, pwd, that prints out the current directory where you are in your computer, because at any time the command line interface points to a certain directory. So anything we do now, for example, let's create a file 1.txt file. Anything we do now is going to be applied to that current directory. In this case, that directory. So if I do touch file1.txt and press enter, that will create a new file1.txt. So touch is the second command you just learned that is used to create new files. Now you'd say, well, how do we see these files? Well, to see the files you have in the current directory is that one again, you should press ls. So there we go, I have many files here and one of them is file1.txt. So that's the file that I've just created and it's an empty file for now. Let's create a second file, touch file2.txt, and let's create a third file, touch file3.py. Let's call this py. Now, if you want to know only the text files, if you want to get a list of only the text files you have in the current folder, you can do ls *.txt. Press enter and that will list only the text files you have in this directory. Actually, only the files that end with a .txt extension, to be clear about that. So that command is saying, oh, give me a list of all the files that have anything in front and then they end with .txt. So touch was how to create a new file. And to create a new directory, you do mkdir, followed by the name of the directory. Let's say data. Right, so I've just created a directory. However, note that you're still in the current directory, as we've been since the start of the command line interface. Now, if you want to do something inside the data directory, first you need to go inside the data directory. You need to change the current directory to that directory. To do that, you use the cd, which stands for change directory. cd data. Be careful with the typos. If you miss something, things will not work. So I created the data folder here and I'm going to that folder now. With that, you'll see that in here, the path changed to data. And you can also double check that with pwd, the command, and it will tell you that you are currently inside data. This is an empty folder, so if you do ls, you're going to get nothing in return, so no files here currently. But any file you create now, such as file 10.txt, any file you create will be created inside this data directory. So with ls, you should get file 10.txt. That's the only file we have now inside data. To go back one directory level, you can use cd space followed by 2 dots, 2 periods. That will take you back to the previous directory. So just check it with pwd. So if you do ls now, you're going to get the files of the C users AS directory. So we saw how to see where we are currently with pwd. We saw how to list the contents of a directory with ls. We saw how to create new files with touch and create new directories with mkdir. Now how to remove a file. To remove a file, you use rm, followed by the name of the file. For example, file1. Now here is a trick I want to show to you. If you want to autocomplete a file name, for example, you do file1 and you don't want to type all the name through, you may press the tab key on your keyboard and that will autocomplete the file name. So file1.txt and then press enter. And that will remove, it will delete file1.txt. So if I do ls now, file1.txt is not here anymore. If you want to remove a directory which has content inside, for example, the data directory, we can use rmr followed by the name of the directory, data. Press enter, and now data is not part of this folder anymore. So you can try to do cd data, but you will get an error. It says no such file or directory because we deleted it in here. How to rename a file? Well, let's create a new file first. Touch file20.txt. To rename this file20.txt to file30.txt, you use the mv command, followed by the name of the file you want to rename, file20.txt, and after that goes the new name you want to give to this file, file30.txt. Press enter, ls, and you'll see that file30.txt exists here, but file20 has been removed. So basically, what mv is actually a move command. It moves a file from one file path to a new file path. So that means you can also move file30.txt to a new directory, for example, data. So let's create the data directory again with mkdir data, and then move file30. So if you press tab while you have just typed some part of the name, for example, I typed in file3 and then I pressed tab and it showed me this. So it didn't autocomplete the name to file30.txt because there are other files which have this name, for example, file3. So the command line interface doesn't know if you want to autocomplete this file or that file. But if you specify a 0, then tab, then it knows that you want to autocomplete that one. I pressed the enter command, but I had to also give the destination of the file. So this is not the correct command. You need to put the destination file. So data file30.txt, and that will move that file to that directory. You can also check the content of a directory without being in that directory. So currently we are in this directory, as, and we can check ls data by specifying the name of the folder. We can check for the files contained in that directory. To copy a file, you use a cp command. Let's copy, for example, file3.py. Let's copy it to data file3.py. Let's check data with ls data, and there we go. File3.py is there. Lastly, let's talk about how to view and how to edit the content of text files. With text files, I mean any non-binary file, such as .txt, .py, .html, .json, all the files which have text inside. So, to open a file for editing, you can use the nano command. So let's create a file first. Let's say touch file50.py. So we have just created a file. Now to open that file, we use nano file50.py. That will open the Nano text editor. So Nano is a text editor which works inside a command line interface. So here you can simply type in text like that. You can press enter, go to the next line, press escape. You cannot even click on somewhere else with your cursor, but you can use your arrow keys to move up and down. So like that. So we can write something here, for example, print hello, and to save and exit this, you can use Ctrl X. You see these commands here. So that symbol means you need to press the Control key on your keyboard, followed by that letter. In our case, we want to exit with Ctrl X. So Control X, that will ask us if we want to save the buffer. If you want to save it, press Y. If not, press N. Otherwise, press Control C to cancel and go back to the editor. So I'll press Y. Then this asks you if you want to keep the file name as it is here or you want to change it. If you want to keep it, you need to press Enter. So what we just did is we added some text to this .py file. And that's something you could also do in a remote server. So the remote server gives you access to its command line interface and you can edit your .py files using the Nano text editor. If you simply want to see the content of a file just to view it, you can use cat followed by the name of the file, file50.py. In this case, press enter, and that will print out the content of that file. In our case, it is print hello. And cat was the last command you needed to learn for today as part of the most important commands. So all these, by the way, all these were Unix commands. Now, these Unix commands work on Linux operating systems, Mac operating systems, and also Windows operating system when you use some tools such as the Git bash. Windows has its own command line as well, which you can find it in here with CMD or PowerShell. And these will be slightly different commands. However, they are not as useful for a programmer as there are the Linux commands, because most of the servers you'll deploy your apps to will be based on Linux. Windows commands are more useful for system administrators who manage Windows servers. So for programmers, Linux will be the industry standard. So I hope you find this useful, and I'll see you later. Thanks.